Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use our fully integrated environment, Fidelity, in short videos of a few minutes. In this video, we will review the hierarchy of geometry elements, look at the camera options to manipulate the 3D view, and learn how to create cutting planes. Once a geometry has been imported into Fidelity, you should see it in the 3D view. If you don't see it, check the following. The little door next to the geometry name should be open. Clicking on the door loads or unloads the geometry into the tree. The eye symbol shows or hides the geometry or the entity next to it. Let's say I want to see the volute only. I can hide the whole geometry, then expand the tree and click on the eye button next to the volute entity. Notice that the CAD tree contains different levels. The highest level is an assembly. It is a container of other assemblies or boundaries. The cube with a shaded face is a boundary. It is a logical grouping of surfaces and will be assigned a specific boundary condition. At the lowest level are the tessellated surfaces making up the geometry. You can expand all the tree elements to the level you need by clicking on the corresponding symbols at the top: assembly, boundary, or surfaces. Moving on to the 3D view, you can use your left mouse button to rotate the view and the middle button to zoom in and out. You can select entities directly by clicking on them in this view, as long as the tree is expanded to the appropriate level. For example, I can expand the tree to the assembly level and select the volute, but if I want to select the outlet surface only, I need to expand the tree to the surface level. On the bottom right of the window, click on the camera symbol to expand it. The X, Y, and Z buttons will orient the geometry about the respective axis. The camera symbol will fit the view to the selected entity. The axis symbol on the left will reset the view to the default position, while the one on the right will toggle on and off the reference coordinate system. The last button is to switch between perspective and orthographic views. Let's talk about a very useful feature that you can find in every context: the cutting plane tool. When clicking on it, an additional element is added under the CAD tree and a property window opens. You can create the cutting plane in the Cartesian, blade-to-blade, or cylindrical frame of reference by giving it an origin and a normal. You can use the X, Y, and Z buttons for preset normal, the N button to align it with the camera view, and the flip button to change which side is being hidden by the cutting plane. The next three entries allow you to translate and rotate the plane. The cutting plane tool can be used in the mesh context to visualize the volume mesh. Simply load the mesh for analysis by clicking on the plot symbol in front of the mesh setup and activate the wireframe visibility on the cutting plane in the cutting plane property window. You can choose between surface and cells intersection. In the result analysis, you can create probes on cutting planes to visualize the solution on them after loading the solution to be analyzed. Here, I created a blade-to-blade cutting plane at 90% span to see the velocity field near the blade tip. You can create as many cutting planes as you want and toggle them on and off as you need using the symbols in front of their names. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming videos like this. If you have any questions or suggestions, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.